Welcome everyone. My name is Sergio Salinas Rodriguez and I am a research associate of the academic group of Sustainable Management of Basins and Coastal Zones from the Sustainability Science Department in the Southern Border College or ECOSUR in Mexico. I am also a guest researcher at the Water Management Department of the Civil Engineering and Geosciences faculty at TU Delft in the Netherlands. I have been working on environmental flow science since 2009-2010, and I have had the opportunity of contributing in the design and development of the Mexican Environmental Flows Norm along its massive implementation and more recently for assessing the Mexican approach for allocating water for the environment. So happy of contributing to IHE Delft Open Courseware. My presentation is entitled Environmental Flows in Mexico, Strategic Setting, Implementation, and Outlook. Well, a little of context. Mexico is the 13th country in the world in terms of surface, nearly 2 million square kilometers. It has around 130 million inhabitants, between 10 to 12% of known species in the world, 180 protected areas, and 140 wetlands of international importance. Its biological richness is greatly explained by its location in the Americas. It is right in two biogeographical regions, therefore is privileged by its diversity in climates and ecosystems, which puts it on the migratory route of hundreds of species. However, as it happens worldwide, there is a dramatic trend in biodiversity loss. Just to give you an idea, endangered fish species have increased more than 10 times in the last 4 decades, 75% of them freshwater dependent. This is also greatly explained by the way in which water resources have been administratively managed. Despite the relative large amount of renewable water resources, Mexico is a country with natural scarcity given its also large extension of arid and semi-arid climates. Historically, water has been allocated for productive use without sustainable limits of abstraction, which has increased the water stress to nearly 75% of the country, where 77% of the gross domestic product is produced. Since 1992, Mexico has a national water law, and since the early 2000s, the environment has been recognized as a legitimate water user. In addition to this, there are complementary norms or standards to ruling water administration and species protection. However, it was until 2012 when the Mexican norm for conducting environmental flow assessments was published. The standard was developed under the leadership of the National Water Commission and the advice of a quite diverse set of government, academic, and NGOs institutions. It highlights the Eflows definition and focuses on the aquatic ecosystems components, functions, and processes that depend on the flow in terms of quantity, quality, and regime. This norm has been used to determine and promote environmental water reserves, which according to the National Water Law, Article 41, is an annual volume of water designated to remain in the environment for ecological protection in this case. This Eflows standard is based on the eco-hydrologic principles such as the natural flow regime, the range of variability of flows, the Eflow components, and, of course, the biological condition gradient and other flow alteration ecological response models, among much more that I am sure you should already know at this point of the course. One key advice I could give you now, from a policy and strategic perspective based on our experience in environmental water allocation, that would be don't waste time on discussing methods, but on the underlying principles to conduct the assessments. Regardless of the method, the approach should adopt the natural flow regime theory and recognize that as far as it is modified, the aquatic ecosystem's integrity will have an impact as well. Different methods offer different scopes and levels of certainty. The bottom question is not what method is appropriate, but what is the underlying purpose of determining and implementing Eflows? Is it for water planning or management, or for investigating the potential effects of a water infrastructure project. The point is to have clear that different purposes bring different needs and scopes of the outcomes. Environmental management class systems, based on the current and desired state of the flow regimes, have demonstrated to be quite effective. In our context, from the country's full set of basins, we selected a group of low pressure and water users and high ecological importance for piloting the Eflows Standard. That basin selection was made basically because in such a set, the National Water Commission felt comfortable enough to try both approaches, bottom-up and top-down, where eco-hydrology, desktop-based, and expert panel methods were used. At that point, the idea was clear. Despite focusing on relatively easy cases, low pressure, high ecological importance, we wanted to taste the scope of the methods at different levels. Please have in mind that e-flows for water planning and management or water infrastructure projects require different levels of certainty in the outcomes. This idea has been key to allocate and expend the funds strategically and to achieve the so-called sustainable balance between water users and conservation at country level that I am about to show. At a country level, nearly 55% of the total surface water has been designated for ecological protection. This means around 65% of the Sustainable Development Goal 642 indicator on water stress. Environmental water reserves from almost 300 basins have been legally protected towards water security for 45 million people. More than 44,000 kilometers of Mexican free-flowing rivers have e-flows legally secured. That is around 33% of the river network. Support 64 wetlands and 82 protected areas. According to our records, more than 600 species would benefit from this e-flow protection. More than 90 freshwater dependent were considered in the detailed e-flow assessments, and more than 40 of those endangered or protected, and around 450 fish species would improve the conservation status. To wrap up, in the last 10 years or so, the progress achieved is crystal clear. From really scarce e-flow on-site knowledge without any regulatory instrument to a robust baseline on e-flow variability indices, clear conservation or management objectives, and reference values for further research. This has been possible due to the decisive commitment of the government for enacting water for the environment despite the lack of knowledge and funding. Such a challenge was overcome by establishing collaborations of trust with academics, NGOs, and funding entities. Altogether, they set the Mexican own road to conduct e-flow assessments and protect them on the long run. Current environmental water reserves look administratively robust, and at a policy level, really promising due to such number is expected to increase by 2024 to cover around 60% of the Mexican basins. However, on-the-ground implementation, adaptive management, and governance are not yet guaranteed. Designing and implementing a water reserves monitoring system to perform regular assessments over time, including rural communities, and demonstrate their climate adaptive capacity is the current task towards achieving an e-flow stewardship both socially and climate sensitive and comprehensive. Finally, I want to thank to the Mexican National Water Commission, the Commission of Natural Protected Areas, the Inter-American Development Bank, and the Alliance of the World Wildlife Fund and the Gonzalo Riorronte Foundation, and the literally hundreds of scientists and specialists that have participated along the years in this initiative. I leave here some references to get deeper into the country case study. Thank you very much for listening.